Welcome to Chapter 7, Proportions and Similarity. Is on similarity, and so these triangles right here, they're not congruent like the triangles we talked about when we were doing all those wonderful proofs. These are similar triangles though. There are a couple things that need to be true for similar triangles. First, all the angles, they're called corresponding angles in the same place, they have to be congruent. So like if this is a right angle right there, that's a right angle, then this one is also a right angle. They're in the same spot. And if this angle, I don't know, maybe this angle is 60 degrees, then this angle over here is also 60 degrees. Okay, and then, but I'm just making up angle measures. Okay, and then this angle and this angle, those have to be the same as well. Okay, so all the corresponding angle pairs, they are congruent, but the sides are not congruent. The sides are what's called proportional. Okay, so the side lengths on this one, if you just count the dominoes, there are 3 here, and 4 here, and 5 here. Okay, it's a Pythagorean triple. Okay, and then this one over here, again, if you just count the dominoes, you'll see, but we've got 6 dominoes on this side, and 8 on this side, and 10 on this side. Okay, so these are proportional, because if you look at these, if you take 3 over 6, okay, so 3/6, and you take 4 over the corresponding side, which is 8, and you take 5 over the corresponding side, 10, all of those fractions would reduce to what? Yes, 1/2 or 1:2. So that's what's called the similarity ratio. So the similarity ratio of the smaller triangle to the bigger triangle here would be 1:2 or 1/2. Okay, so in order for triangles to be similar, the angle measures have to be congruent, and also the side lengths need to be proportional. But what if we had something like this? Okay, over here we know these 2 sides are 4 and 6, even though they don't count to that many dominoes, but don't worry about that. And then this one is 8, but we want to know this side. How would we figure that out? So if you know that triangles are similar, then you can use a proportion to find a missing side. Okay, so if I go like small triangle to large triangle, okay, then the left side of the small triangle is 4 over the left side of the large triangle, which is 8. And I'm going to set that equal to another small over large, so 6 over x. Okay, and then you've done this in Algebra 1, but now what we're going to do is we are going to cross multiply. So I'm going to take 4 times x, okay, 4x, and set that equal to 8 times 6, which is 48. And then I'm going to divide by 4, and I get x is equal to 12. Okay, so this piece right here, that's 12. Okay, and if you look at this, these numbers were pretty easy anyway, so you could just see that when you go from 4 to 8, you double it. When you go from 6 to 12, you double it also. Okay, so if you see a shortcut, use it, but generally there won't be one.
Hi! So we are going to do a little experiment to test out our proportion lesson that we just learned. So I really want to find the height of this tree, and it's just too tall. I don't know the height of it. So I want to figure out the height of it. So we're going to do this by knowing that I am 5'6", and we are going to measure my shadow. All right, so we're going to measure from my feet to the tip of my shadow. How long is my shadow?
Way long. 11 feet and 7 inches.
11 feet and 7 inches. Okay, so the next thing is we're going to measure the length of the tree's shadow. So here we go. 6 feet, 9 feet, 12 feet, 15 feet, all right, so we're at 16 feet and 1 inch. That is the height of the tree's shadow. Okay, so now we're gonna do some math to figure this out. You can turn it off.
So how tall is Mrs. Wagner's apple tree? Here is a beautiful representation with lovely drawings, but we don't know the height of the apple tree. We know the shadow is 16 feet 1 inch. We know that I'm 5 feet 6 inches and my shadow is 11 feet 7 inches. Okay, so we can set up some similar triangles, just like this. Okay, and so what we need to do though, we need to convert this all to inches because we've got feet and inches. In order to do our calculations, we have to have it all in the same units. So for my height, I'm 5 feet 6 inches, and so I'm going to change that. I'm going to take the 5 times 12 and add 6, so that's 66 inches. And 11 feet 7 inches, that's 139 inches. And the 16 feet 1 inch, that's 193 inches. Okay. So now I'm going to go to my calculations. Okay, so first I'm going to set up my proportion, and I'm going to go height over shadow. So for the tree, we've got x over 193. For me, got 66 over 139. Then I'm going to do my cross multiplying. So I'm going to multiply diagonally. And so I get 139x equals 12,738 divided by 139. And I get approximately 91.64 inches. So then to put into feet and inches, I'm going to divide by 12. So I get approximately 7.64 feet. Take the decimal part, multiply by 12, and I get approximately 7 feet 8 inches. So that is the height of the apple tree.
Hi, all right, so we did all those figures, and I just want to make sure that our math is correct. Okay, so I want to find out if we got the right height for my apple tree. And since I don't really know how tall it is, I'm going to give a call to my friend who knows stuff and just see if he knows how tall my apple tree is. Okay, so I'm just gonna give him a call here real quick.
I love your stuff so much.
I hope he's home.
Friend who knows stuff, how may I help you?
Oh, hey, so friend who knows stuff, I was just wondering, so I am here with my class, and we are figuring out, using proportions, how tall my apple tree is. And since you're my friend who knows stuff, I was just wondering if maybe you could tell me how tall my apple tree is.
Well, how old is the apple tree?
It is almost almost 2 years old.
2 years old?
Mm-hmm.
So it can't be too tall yet, huh?
It's true. True.
Have you ever thought of maybe just using
Well,
meter
okay,
stick
no. Let
and-
me just say this though. It's 2 years new to us. I mean, like maybe it's a little bit older, but yes, it hasn't grown a lot.
Okay, well, as I was saying, have you ever thought of just using a meter stick or something and measuring how tall it is?
Well, do you think that'll work? I mean, I couldn't reach it with my. Oh, so you mean just hold it up a little higher?
Yeah.
So I could just
That's
measure.
what I do.
I could just measure
I
it
seem to know
myself.
stuff.
Okay. All right. Well, thanks, friend who knows stuff. I appreciate your help.
Anytime.
All right. Thanks. Bye. That was helpful. All right. So I am just gonna go right over to this tree and measure it because really, I mean, come on, common sense here. Okay. So let's see. There's the top. So there's 3 feet. Hopefully I'm not moving my hand too much. There is 6 feet. And then we've got 7 feet, 8 inches. And that is what we got. So I believe we got it right. Yeah. All right. So this really wasn't a very good example because I could just measure this, but look over at that tree. That one's a little taller. So do you think it would work with that one too?
Yes.